All right, we've got an isosceles triangle, PQR, and it says the radius is 1. So, and QOR, the angle is 2 theta. So the angle at the center is 2 theta. Now, if I make this, if I cut that in half, you can see that if that's O and they said to extend it and make it M, whoops, which I didn't do, there we go, so that's M there. So if I go just from O to M, this is now theta, because it's half that angle, this is Q there. Alright, so if we have a look at QM, M we know, we also know that this is the radius here, that length is a radius, and we know the radius is 1. So using that, we know that, I'll do it over here, sine theta, if I'm looking at that little triangle, some old tags, is QM on OQ, and that's just QM on 1. So QM is equal to sine theta. And if I look at cos theta, can't always hide, we've got OM on OQ, again, OQ is 1, so OM is equal to cos theta. Alright, so once we know that, let's have a look now at finding the area, okay, of PQR, so this whole triangle there. So if we think about it, we've got half the base being QR, and the times the perpendicular height, which is that PM. So half the base times the height, perpendicular height. Now half of QR is QM, so actually I'll just do really more working than I usually do. Half of QR is QM, and then PM is made up of PO and OM. Alright, so doing that because we know what QM is, do we? We should know what QM is. QM is sine theta. Oh, there it is. QM is sine theta. Alright, what are we multiplying by? PO. Now, PO is just the radius, again, because that's the center. So I've got a 1, and OM, where's OM, is cos theta. So you can see that, yes, the area is sine theta times cos theta plus 1. I've just got it back to front. Alright, and now we're looking at the maximum possible area. So we're maximizing. So dA d theta, because there's thetas in here. So we can differentiate with respect to theta. So if I could do product rule, so there's U there, and there's V there, so differentiate the first, times by the second, plus differentiate the second, oops, that's minus sine theta, times by the first, which is sine theta, so I'm just going to put a square there. Alright, so let's just change that to cos theta plus, I'm just expanding that one, cos squared theta. This is minus sine squared theta, which is the same as sine squared is 1 minus cos squared. If we put that all together, we've now got 2 cos squared thetas. We've got a cos theta, and we've got a minus 1. Now that can be factorized nicely, because remember I want this to equal 0. So let's just go up here. So that would equal 2 cos theta, and cos theta gives me 2 cos squared theta, and I need a 1 and a 1, and I want a positive 1 cos theta, so that's going to make that positive 2 take away 1. There we go, that works. So actually, if I now make that equal to 0 to solve it, what have I got? I've got cos theta equals a half from the first bracket, and cos theta equals negative 1 from the second bracket. Now the trouble with that is we have got theta being acute, it's an acute angle, so think of the cos curve. Oops. So I only want this section, but that doesn't give me negative 1, negative 1's down here, so this one gives me no solution. That's no solution for theta is acute. Whereas acute angle for this one we know is 60 degrees, so pi on 3. So we're looking at pi on 3 as being a stationary point, but remember we need to show that it is indeed a maximum stationary point. So let me make a bit of room. Hopefully we don't need that bit. And that was our no solution, so we don't need that bit. Okay, so let's have a look at then d squared a d theta squared, so our second derivative. I could do it straight off here. Doesn't really matter. All right, so 2 cos theta all squared. So the 4 comes down. It becomes just cos theta, and then times by the derivative of cos theta, which is negative sine theta. Cos theta goes again to negative sine theta, and negative 1 goes to nothing. So I could factorize by negative sine theta, and I would have 4 cos theta plus 1. If I sub in theta is pi on 3, I've got the squared a to theta squared being minus sine 60 is root 3 on 2. 4 lots of cos 60 is a half plus 1. So we're going to get negative root 3 on 3 root 3s, because 2 plus 1, whoops, I'll go negative 3 root 3 on 2, which is indeed negative. So if we think of that, therefore it's a maximum. Okay, so therefore what did I ask for? Hence show that as theta varies, this triangle has a maximum possible area when it is equilateral. Oh, yeah. So of course, if that means that that angle, our theta is pi on 3, because remember, I don't know if you know this, so double angle at center means one single angle at the circumference. So that must be pi on 3, but remember these were the isosceles triangles, base angles are equal, so they must also be pi on 3, which gives us an isosceles triangle. So the maximum area occurs when theta equals pi on 3, and if theta equals pi on 3, then all the other two vertices are also angles of pi on 3. Hence, it's an equilateral triangle that gives us the maximum possible area.